All right, so let's answer these tutorial questions. So we are on question 6, 7, and 8. If n plus 1 factorial is equal to 5 n factorial, so for n, all right, we'll start from there. It's a very easy question. So n plus 1 factorial is equal to 5n factorial. How do you solve for n? So here's what we do. Recall that if I give you 6 factorial, how am I going to write this? This is just the same thing as 6 multiplied by 5 factorial, which can also be written as 6, 5, 4 factorial, and so forth. So we can also transform this as n plus 1. Are we there? Ka? Then, what to follow? Then n factorial. This is just equal to what? 5n factorial. So that factorial and factorial can cancel. Take note that there's no factorial here. So this and that can go. We get 1 plus 1 is equal to 5. This will give us n is 5 minus 1, which will give us what? N is equal to 4. We can prove this if you want. You can prove. All right, let's come here. If I put 4 plus 1 factorial, I'm getting 5 factorial, which is just 120. Let me get the other side. If I get 5n factorial, this will give me 5 multiplied by 4 factorial. What is 4 factorial? It's just 24. To still give you 120. So you can say that it holds. It holds, right? Exactly. On to the next one. I'm going to erase. The next one is question 7. It's saying that show that n1 that is equal to n. All right, so when you see this, it's just a binomial. This is just a binomial coefficient. And you recall that the binomial coefficient, all right, any k can be anything. You can have r, t, it's up to you. It's usually given by that over k factorial n minus k factorial. I think you know this. So we do the same here in the same manner. So let's go. So n1, all right, will be equal to n factorial over 1 factorial, then n minus 1 factorial, like that. And recall that n factorial is just the same as n in brackets n minus 1 factorial, because this they keep on decreasing by 1 over this will be 1, then n minus 1 factorial. That and that cancel, we get n. Shown, right? Good. Part 2, we are showing that n2, like that, at n2 is equal to what? We are showing that is equal to n open bracket n minus 1. All right, so we do the same. So this will be n factorial over 2 factorial, then n minus 1 factorial. Key thing is to eliminate this down here. All right, so how can you write this one here? We can write n factorial can be written as this: n minus 1, n minus 2 factorial. You agree, right? Sorry, it's 2 here. It's 2 there. So we need to have a 2 here so that it can cancel with the n minus 2 factorial down there. The n will keep on decreasing by 1 by 1 by 1. We know that. So this and this gone. So end up having n minus 1 over 2 factorial, just 2. Hence shown. That's all. We go to question 8. You've seen how easy they are, right? All right, next, simplify the factorial. So let's start with number 1. 2n plus 2 factorial over 2n factorial. How do we simplify that one? All right, so don't chill. It's very easy. All right, so we can just keep on decreasing the upper part by 1 until we get to n factorial. Let's go. So 2n plus 2, all right, if I decrease by 1, I'm going to get 2n plus 1, right? Because 1 will subtract 1 here. Again, this can be 2n quasila. Then factor at the end like that. I'm decreasing this one by 1 and I'll keep on decreasing. But I've gotten something which I want down here. So these can go. So what will remain with it? We can expand that if you want. It's literally it's up to you. If you want, you can go on. You say, but for me, I'll just write like this. I think when I reach this stage, I think it means you can know what to do from there. The next one is n plus 1 factorial over n minus 1 factorial. So how do we get this one? We'll keep on decreasing. Let's go. So if I'll maintain the first one. If I decrease this one by 1, I'll get n. If I decrease n by 1, I'll get n minus 1 factorial at the end. And I'll have n minus 1 factorial down there. So factorial, gone. So I'm going to have what? N plus 1 multiplied by n, which you can write as n squared plus n. Still the same. Got it? You are welcome. Thank you so much.